Hi, I'm an old guy and I do maths, and today we're looking at smoothing techniques and in particular odd moving means. Now, an odd moving mean simply means that we calculate a mean using 3 or 5 or 7 pieces of data. In this case we're going to use 3 because we've got a very small amount of data here. And this is used when we have single data points over time, as in we have a time series. And down the bottom here, I've just put seasons: autumn, winter, spring, summer, autumn, winter, spring, summer. And what we're looking to do with this is to smooth out the lumps and bumps in this data series. So let's get to work. The first thing we're going to do is we're going to find the mean of these 3 pieces of data. And what I've got here is my working for some of this. I'm not going to do the whole series, but I'm going to do enough that you understand what is going on. So the first thing I do is I just set up this little, I suppose you'd call it I don't know what you'd call it, but I set up this little diagram, I suppose. And what I do is I link the first 3 pieces of data, and I put a line out here, and I add them up and divide by 3, which gives me my mean, and we'll get to that in a minute. Then I move along 1 piece of data, and I do the same. 3 pieces of data, add them up, divide by 3. Then I move along 1 more, 3 pieces of data, and so forth and so on. You get the idea, you get the pattern. If you were looking at it on here, first 3 pieces of data, second 3 pieces of data, third 3 pieces of data, fourth, and so on. Right, well, let's get into calculating these means quickly. Right, so what have we got? 8 plus 5 plus 7 divided by 3. I'm just going to write this in red. This is 6 2/3. 19, 5 plus 7 plus 7 divided by 3. That is 6 1/3. 7 and 7 is 14, and 6 is 20. 20 divided by 3. I think we're going to be back at 6 2/3. It's the same, pretty much the same as that. So 6 2/3. 6 and 5 is 11, and 7 is 18. We're at 6. Put a bracket around this. 6 and 6 is 12, and 5 is 17. 17 divided by 3 is 5 2/3. You can do this with decimals, I just happen to do it with fractions. 6 and 3 is 9. 9 and 5 is 14. 14 divided by 3 is 4 2/3. So these are the moving means, the means of 3 points moving left to right as we go through this. And what you can see is that the numbers are falling off. Now let's plot this. And the important thing to note is that our first plot is in line with the second piece of data here. So what I've done is I've centered these numbers, and this is the center of them, 8, 5, and 7. So we're centered here, and so we go up here to 6 2/3, which is approximately there. 6 2/3, I hope you can see that. Yes, that's in focus on the camera. My next piece of data is 6 1/3. So I'm now just working down through this. And then 6 2/3. And then 6, I'm just going to circle that to show that the actual data is on top of the averaged, and then 5 2/3, which is here, and then 4 2/3, which is here. Okay, now you're not going to see the effect of this until I join the dots, so I'm going to do that now, and we'll just do this for all of the blue data, and then I'm going to join the red dots. And there are a couple of things to notice. The first thing to notice is that our first piece of averaged data is here. It's in the middle of the first 3 data points. So a 3-point moving mean starts 1 in from the first piece of original data. It also finishes over here, somewhere around here, 1 point in from the last piece of original data. As I said, I didn't do them all because it just becomes boring after a while to watch me calculate these means. The second thing that I want you to notice is how much smoother this line is than this line. Now, I'll add one thing to this. Had we done a 5-point moving mean, starting off with this, and this point, our first data point, new data point, would have been here. And this line would have been even smoother. So, generally speaking, I can't think of an exception to this, but I will say generally speaking, the larger the size of your moving mean, moving from 3 to 5 to 7 to 9 to 11, the smoother your resulting chart of a moving mean will be. What does this do? Well, it quite simply smooths out the data. It takes out the big troughs and the big peaks, and it's much easier to see a trend line. Not that this is particularly difficult to see. This is trending in a negative direction over time. Okay, so I hope that was fairly straightforward. It's not a particularly difficult thing. The trickier thing is indeed the even moving mean, which there is a video on, which I will link this to. Anyway, if you found this useful, please like and subscribe, and I'll see you next time. Bye.